Okay, so when we're talking about laws of exponents, we have one key thing that you always have to keep in mind, and that is this right here. All the rules that we're talking about, when you're talking about multiplying, dividing, whatever you're doing with them, you've got to have the same base. If you don't have the same base, then the rule doesn't apply. Base is the big number. Okay, so these are all, we have B as the same base. We have rules that apply to those. If we've got the same base, whether it's numbers or letters, then we can add the exponents together.
So like x times x, you keep the x, right? Add the 3 and 5.
Now, when we're talking about expanded form, I say this every single year, and it still happens. If you're getting it right and you're following the rule, fine. If you are not, and you're missing them, and you're not writing it out, then you're making things way hard on yourself. So, expanded form. That means that we have 3 x's and 5 x's. Now, when you get really big numbers, obviously it's going to be a problem to write all those out. If we add them all together, we get x to the 8. The rule gives us a shortcut that says we can simply add those together and get our 8.
Oh, cool.
So if you're not missing them, then you can use that rule. But if you're missing things, which for example number 2 is one that tends to be an issue, what's understood to be on this last y? What exponent? 1. There's nothing there. It's a 1. This is a big problem. I get this as an answer a lot of times, and they're like, well, I canceled all out. Okay, but that's not canceled all out. That's 1. If it cancels all out, then you need to have a 1 or y to the 0. Okay, we're going to see this on another one. But that right there is not the same as this. Those are 2 different things. So you need to be very careful about the exponents and things that you're doing. So if we add these up, we have 3 y's, 4 y's, and 1 y. Now I'll kind of separate them a little bit just so you can see the difference. But it's all multiplication. So if we multiply all that together, we have y to the 8. So our shortcut would be to add our exponents and get 8. Now it seems pretty simple when you're talking about one letter.
Oh, dude.
Or one number. But when you start getting them more involved, you're going to have to pay attention to your bases. You can see multiplication written with the dot or with our parentheses. Parentheses mean the same thing. I have 2 m's here, 3 m's here, add them together, and you get to the 5th. On 4, 2 different letters, A and B. Split them up. This is what I'm talking about. Writing out may be helpful. We have 3 A's, 2 B's, 2 A's, 4 B's. So if we combine all of our A's together, how many do we have?
5.
5. So I have A to the 5th, B to the what?
6.
6. If I use the rule, I simply add the A's and add the B's. So if we use this, same rule as we did above, I'm not going to write these all out. Let me use the rule. 2 to the 3rd times 2 to the 8th. I'm going to add my exponents to get 2 to the 11th. That's our exponential form. Now, put your calculator. Does anybody know where your exponent key is?
Yeah, it's right there.
So find 2 to the 11th. What do we get?
2040.
2048.
So we said this was 2048. Okay, so the next one, number 6. We have 5 to the 4th and 5 to the 2nd. So we get 5 to the what?
5 to the 6.
6, which is what?
5 to the 6 with my homies 15.
15,625.
Okay, 15,625. Now, number 7. I've said this over and over and over and over. And some people still refusing to listen to me. And it's going to cause you a problem.
So it's just gonna be -3 to the 5th
If you
power.
have a negative number, it must be in parentheses. If we have an odd exponent, we put these together, we get -3 to the 5th power, which is -243. If you have an odd exponent, it's not going to matter in the calculator. So you're going to say it doesn't make any difference. However, let's try another example here. If I have -3 to the 4th, and I have -3 without parentheses to the 4th, everybody put your calculator and look at what you get.
Oh.
That's just quick. -81.
One's positive 81, one's negative 81. Those are two different
Oh.
things. Because this one up here, if I were to write this out, means -3 times -3 times -3 times -3. Okay? Well, if I multiply those negatives together,
It's gonna be a
I
negative.
get a positive.
Wait, what?
4 negatives together, an even number, gives you a positive.
Oh, 4 of them.
This
right.
one doesn't do that. Definition of an exponent says it applies to the number or letter directly before it. This means do 3 4 times, which is 81, stick the negative on it. Okay? The negative counts 1 time here with 81. It counts 4 times there. So when you're looking at your problems, you need to be sure that if this is in parentheses, that it stays in parentheses. Because it makes a big difference. Okay, number 8. Normally you see from least to greatest, so how many 2's do we have?
9.
9. When I say how many 2's, I don't mean the number you see, I mean the exponents. How many 3's do we have?
We have 3.
Okay, put it in your calculator.
Trace.
539. Oh, what
I
the?
don't think so. 2 to the 9
I
times 2
put,
to the 3rd.
oh, you multiplied. I put.
You have to multiply. That's what it's doing. It's multiplying. So,
13,824.
13,824. So, when we're dealing with basic multiplication, we're going to keep the same base, we're going to add the exponents. If it says 2, if you have a number involved, then you need to multiply it out. When we have a coefficient's the number that's in front of x, then you're going to have to multiply those together. Because the rule only applies if the base is the same number. So if we look at number 9 here, what are the exponents on the 2 and the 5?
24?
No, the exponent on the 2.
Oh.
3.
Is it in parentheses?
No.
No. It's a 1. What's the exponent on the 5? 1. That's different if you had this. If I had this, which we're not doing today,
Amen.
you would have all of them. That's not what we're doing. We have 2 one time, x 3 times, 5 one time, x 4 times.
Whoa.
So what's 2 times 5?
10.
10, x to the
To the 7th power.
7th power. Number 10, the 6 and the -6 and the 5 have understood exponents of 1. There's only one of them. So, -6 times 5 is -30.
Amen.
They don't have the same base, so I'm just going to multiply them together. Y to the what?
Y to the 12th power.
12th power.
We can't use this in the calculator.
Now, look at your division law of exponents. This is the one that you especially can make things extremely easy or extremely difficult. What's anything divided by itself?
It's 1.
1, right?
1.
3 by the 3 is 1, 2 by the 10 is 1, x by the x is 1. So, the rule says that, again, if we have the same base, we can subtract the exponents. That's the shortcut. So I can go straight from b to the 5th over b to the 3rd to b to the 2nd, using the rule. However, we need to write a lot of these out. Because these are the ones that are missed a lot. If we write this out, b to the fifth, it's 5 of them. b to the third. Every time we have one top and bottom, cancels out. You need to ask yourself the question. I want you to write this out to the side. Which has more and where? You need to be thinking about that. Which has more and where? What I mean by that is this. Now look at B's. Which has more, top or bottom?
Top.
How many?
2.
2. So, this could be written as b squared over 1 or just b squared. Because we're going to look at some later that may be the other way around. If it had been this way, and I say, which has more, the bottom, how many, 2, that's what it has to say. It doesn't magically go up to the top, just because you don't like a fraction. If there's nothing left up there, put a 1. But that question is extremely important. If you have more letters on top, where your answer goes. If you have more on bottom, your answer is fraction. Okay, fractions are not bad. Okay, when we're talking about all these things, you're going to have a lot of them. So you need to be careful. And notice in the thing up here it says for any non-zero number b. Why would b have to be non-zero?
B would be non-zero because B is non-zero.
Can you divide by 0?
No.
No, that's why it has to be 0. Base can gotta be 0. So, that's why it says that. Okay, so if we look at this, again, if you can follow the rule, you're not missing them, no problem. If you're missing them, you need to be writing it out. So, if I have x to the 7th, 2, 3, 4, 5, 6, 7. On the bottom, 1, 2, 3.
Do we have to draw all those X's?
I want you on this one too, but on later you don't have to. So, if I have 7 on top, 5 on bottom,
X.
then I'm left with 2 of them, and it's on the top,
X
so I can
over
write it
A.
as x squared.
Or just X squared?
You can write it over 1, but it doesn't matter there. The rule says that I can subtract 7 minus 5 and
So it
go
doesn't-
straight to 2.
It doesn't have to be a fraction? Okay.
On bottom it does, not on top. Okay, number 2. We have y to the 5th.
It'll be Y4.
Because I have one y down here. I would
Okay.
suggest that on all of your problems, if you've got a single letter, that you go and put the 1 there.
Put a 1.
It's going to make it a lot easier for you later.
And 1.
Therefore, I can say 5 minus 1 is 4, or I can mark that one out. We're left with y to the 4th. Okay, number 3. We're going to do subtraction.
Wait,
Not skip it. Okay? It may be difficult to write them out because it's a fraction. This is why the rule is helpful. What are we supposed to do with those?
Cancel them out.
No? What does it say do with them?
Subtract.
Subtract the exponents. So,
So it'll be,
5 over
equals
2.
4.
minus 1 over 2 equals 4 over 2. What's 4 divided by 2?
2.
2. You can do that in your calculator. If I say, if you have to, 5 over 2 minus 1 over 2 gives me 2. If you get something that gives you a decimal, after your inner. Okay, you can have exponents that are fractions. What we will do eventually, no, I don't know if we will, but what you will eventually do is that if you had something like that, m to the 1/2, it means this. Okay? Because it means it's the cubed root of m squared. So, I mean, there, at some point, we will be doing those
The roots.
with fractions, with square roots, and others, and so on. So, but for us, that's what we're dealing with right now. That's on 4. Think about my fraction line here. I can write those out. I have 3 A's up here, 6 B's. On the bottom we have 2 A's,
It's gonna be A1
3 B's.
times B3.
So, if we cancel out, got 1 A, 3 B's. So we have to keep the 1 on the A?
Yes. Well, you don't have to, but.
No. So probably if you're seeing it as a multiple choice answer, you would simply see it as this.
Haba.
I'm not going to count it long enough.
A lot.
But that way you could tell.
Halo.
Okay, the same thing applies when we're talking about numbers. So if we look at number 5 here. 2 to the 9th over 2 to the 6th. What's our base? 2. Same base, so I'm going to keep my base. What do we with our exponents?
96, it would be 3.
Okay, I'm going to subtract, so I get 3. And what's 2 to the 3rd?
2 to the 3rd is 2 times 2 times 2, 8.
Is 8. Okay, so I want you to take a couple minutes and
Would that then be 8?
look at you've got to look at each part separately. If they're not lined up, then just look at them as each part. So if we look at our 2's, where do you have the most? Top or bottom? Top by 1. 5 minus 4 is 1. Where are the most 3's?
Top.
Top by 3. Then put your calculator. 2 times 3 to the 3rd. That's 2 times 27, which is 54. You have to do this first before you multiply by 2. Right? If you put your calculator in the right order, it's going to do it for you. Okay, so down here on 9 and 10, one thing I like to do on these, if you've got a lot of numbers and letters involved and you're not sure about top, bottom, where you're going to have it left over, go ahead and draw your fraction line. What's 24 over 3 reduced to?
21.
8. You're dividing.
8.
24 divided by 3. Get that question all the time. What do I do with numbers? Whatever it says do. That line is division. 24 divided by 3 is 8. We have more x's on top by 4. So there's your answer. You know anything on the bottom. But over here on 10, we have that 7/3. So negative 6 over 5. Can you reduce that without a fraction, without a decimal?
No.
No, so we're going to leave it. Negative 6 on top, 5 on bottom. Now look at your letter part. We have 7/3 minus 2. So I'm looking at my calculator here. 7/3 minus 2 gives me 0.3333, so on. How can we change that to a fraction? So we got a math inner, tells me 1/3. So over here, I end up with y on top, because there's more up here, to the 1/3 power. You have to get over your aversion to fractions, because there's bunches of them. Okay, now down here at the bottom, the rule says this. If you have zeros and exponents, anything to the 0 power is 1. So I want you to write that out beside it. Anything to the 0 power equals 1. Because it says when numbers divided by itself, the result is always 1. So any base with a 0 exponent is going to equal 1. If we look at just this, b to the 3rd divided by b to the 3rd equals 1. So the middle steps here, if we follow the rule, we're going to get b to the 0 equals 1. That's not the same thing as b. So I get this a lot, where I get b to the 3 minus 3 equals b. No, it equals b to the 0, which then equals 1. That makes a big difference.
The thing that would equal b would be